हेलो विद्यार्थी मित्रों, chapter number 5. Let us come for lecture number 5. Last time we stopped at to find the derivative of the inverse function. Today let us start with that point. See, we already seen these two sums. We have to start with y is equal to sine inverse 2x upon 1 plus x square. Clear? So y is equal to sine inverse 2x upon 1 plus x square. Here condition is not given, but condition is here mod x less than 1. See, as far as differentiation is concerned, function is always differentiable on open interval. Now, sine inverse consult or cos inverse consult. At that time, range is mod x less than or equal to 1. But that thing in chapter number 2, not for here. Here we have to see the open interval. Now, sine inverse is there. Can you guess what can you say about this one? 2x upon 1 plus x square, sine 2 theta in terms of tan. So suppose sine inverse x is equal to theta. So x is equal to sine theta. What can you say about mod x less than 1? Now minus 1 less than x less than 1. Here, tan theta, no. Suppose tan inverse x is equal to theta, and therefore x is equal to tan theta. Why? Because this is a formula for tan theta upon 1 plus tan square theta. That is the standard form of sine 2 theta. So we are supposing in that term. Now x is equal to tan theta. For which value of theta we get 1 in terms of tan? Tan pi by 4. What can you say about here? Minus tan pi by 4. But tan is odd function, so can I write here tan minus pi by 4? Yes, we can write it. Now this implies minus pi by 4 less than theta less than pi by 4. Why? Because tan is increasing in every quadrant. Here. Now, see, this is not a range of any function. As far as tan is concerned or sine inverse is concerned, in terms of sine inverse, it should be in closed interval minus pi by 2 to pi by 2. While in terms of tan, it is open interval minus pi by 2 to pi by 2. It is formula of sine 2 theta. So here we need to multiply by 2. So this implies minus pi by 4 less than 2 theta, minus pi by 2 less than 2 theta less than pi by 2. Now it is in terms of range of sine inverse. Now what is y? And therefore y is equal to sine inverse tan theta upon 1 plus tan square theta. Now recall that standard form 2t upon 1 plus t square. That is the formula of sine 2 theta in terms of tan. So here we will write sine 2 theta. And we know that sine inverse of some function is equal to some function. Only when that is in range of sine inverse. Of course it is in between range. So that is equal to 2 theta because this one is range. 2 theta is range of sine. Is it clear? Yes. Now replace value of theta. What is value of theta? That is equal to 2 tan inverse x. this is the example, totally example from inverse trigonometric form. And this type of so many sums already seen. Here, now come on differentiation. And therefore y is equal to 2 tan inverse x. See, differentiate with respect to x. So d by dx of y, that is dy by dx, is equal to d by dx of 2 tan inverse x. Now apply working rule of differentiation. Here constant quantity is there, so take it common. And we know that as far as calculus is concerned, that means either limiting process is there, the derivative is there, or definite or indefinite integration is there. Then we can take constant quantity common throughout. Here, so as far as calculus is concerned, we can take constant quantity outside. Now tan inverse some function d by dx of some function, 1 upon 1 plus some function square into d by dx of some function. So ultimately it comes out 2 upon 1 plus x square. Is it clear? Yes. Next one. Now see. What is given? Y is equal to tan inverse. In terms of tan, 3x minus x cube upon 1 minus 3x square. See, recall that standard form, tan 3 theta in terms of tan, that already seen in 11th. 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta is the standard form of tan 3 theta. So what do we have to suppose here? Suppose tan inverse x is equal to theta, and therefore x is equal to tan theta. Then use given range 0 less than x, minus 1 upon root 3 less than x, less than 1 upon root 3, x is equal to tan theta. For which value of theta in terms of radian we get 1 upon root 3? Yes, we know that is 10 pi by 6. And so here minus 10 pi by 6. But tan is what a function. So tan of minus pi by 6 less than theta less than 10 pi by 6. Now we know that tan is increasing in every quadrant. So minus pi by 6 less than theta less than pi by 6 as tan is increasing in every quadrant. Clear? Now see, is the standard form of 3 theta, so we need to multiply by 3, minus pi by 2 less than 3 theta less than pi by 2. Yes. Now replace value x is equal to tan theta in this form. So therefore what is y? And therefore y is equal to tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Yes. Now recall that form. That is nothing but tan inverse tan 3 theta. And we know that tan inverse of tan some function is equal to some function only when it is lies in the open interval minus pi by 2 to pi by 2. Of course it is in that part. Because of minus pi by 2 less than 3 theta less than pi by 2. Yeah. Once again it is a sum from inverse trigonometric form. So therefore what we get, y is equal to 3 tan inverse x, replacing value of theta. Now nothing but only one liner part remaining there. Differentiate with respect to x, dear friends. There is a half marks for to write this line. Because here we want dy by dx. That means here we need to differentiate with respect to x. Later on we are going to see later on. We are going to differentiate with respect to t, with respect to theta, likewise. So we need to mention that line compulsory. And therefore dy by dx is equal to d by dx of 3 tan inverse x. So 3 constant, take it outside, d by dx of tan inverse x. 3 tan inverse something, 1 plus something square into d by dx of something means some function. So ultimately we get 3 over 1 plus x square. Yeah, very simple forms are there. Here also see. The cos inverse 1 minus x square 0 less than x less than 1. So what will we take? Suppose I am taking here once again tan inverse x is equal to theta because 1 minus t square upon 1 plus t square is the standard form of cos 2 theta. That is cos 2 theta in terms of tan theta. And it is hint is there 1 minus x square upon 1 plus x. So we need to take tan inverse x is equal to theta. So ultimately here we get x is equal to tan theta. Now use given condition 0 less than x less than 1. What is x? Cos theta. For which value we get cos 0? Yes, cos pi by 2. And for which value we get 1 cos 0. Now put here pi by 2 theta 0. Can I write here less than? No, greater than. So order sign changes because of cos is decreasing in first quadrant. So write in our manner, in our order, simple order. This implies 0 less than theta less than pi by 2. It is formula cos 2 theta, so we need to multiply by 0 less than 2 theta less than pi. That is the range of cos inverse. Now replace value in that form. What is y? Cos inverse 1 minus tan square theta upon 1 plus tan square theta, replacing value of x. So that is equal to what? Cos inverse cos 2 theta. Once again that comes out 2 theta because the cos inverse cos some function is equal to some function only when that is in between 0 to pi. Of course here it is in between 0 to pi. Now replace value of theta to tan inverse x. So what we need to do remaining small part. Therefore y is equal to tan inverse x. Mention that line. Differentiate with respect to x. Why am I writing speedily? Because that we know very well. d by dx of 2 tan inverse x. 2 constant term. Take it outside. d by dx of tan inverse x. So tan inverse something 1 plus something square d by dx of something. Ultimately it comes out over 1 plus x square. Okay. Very simple forms are there. Next one. Yes, see. This one is slightly typical some orders. Here 1 minus x square upon 1 plus x square is given. What we have to take? X is equal to tan theta. Tan inverse x is equal to theta. That way. So suppose tan inverse x is equal to theta. So what we get? X is equal to tan theta. Now 0 less than x less than 1 is given. Here tan theta. Clear? So what we get? And here, please tell me. 1 tan pi by 4. And here we get tan 0. Okay. Now tan is increasing in every quadrant, so 0 less than theta less than pi by 4 multiplied by 2. 0 less than theta less See, we already done some mistake in previous sum. See, let us first, after this one we are going to see that sum also. Because I started with cos. No, that we are going to see in terms of, there is also 0 less than x less than 1 is given. So replace this part in previous example. So in previous example, what mistake done by me? I have started with cos here. No. Because our substitution in terms of 10, so we need to see with 10. So same part is there in the previous sum. Please correct it. Clear? Yes. Now, what is y? And therefore, y is equal to sine inverse 1 minus tan square theta upon 1 plus tan square theta. That is equal to sine inverse cos 2 theta. But see, that is equal to, before we know that, sine inverse x plus cos inverse x is equal to pi by 2 mod x less than 1. So here 0 less than 2 theta less than pi by 2 is given. This says that 0 less than cos 2 theta less than 1. So we can convert in terms of cos inverse cos 2 theta. That is the change in this example. This is the reason why this example is important for us. Now it comes out pi by 2 minus 2 theta, because there is 2 theta, 0 less than 2 theta less than pi by 2. Of course, it is a subset of range of cosines. So replace value pi by 2 minus 2 tan inverse x. So differentiate with respect to x. So what we get? dy by dx, d by dx, so pi by 2 minus 2 tan inverse x. Yes or no? Yes. So that is equal to d by dx of pi by 2 minus 2 tan d by dx of tan inverse x. Yes or no? Yeah. It's a constant term. So derivative is 0 minus 2. Or tan inverse something. 1 plus something square d by dx of something. That is minus 2 over 1 plus x square. Yeah. Yes. So, dear friends, please correct this mistake done by me in previous sum. In previous sum, replace this part there. Clear? Where in place of the radical cos, that part is wrong. So please correct it. Only that this pick up this part from here and put there. Same thing is there. Next. See. Now it is very easy. Now in terms of sine inverse. See. Right? What we have to suppose? Suppose tan inverse x is equal to theta. Once again, tan inverse x is equal to theta, and therefore x is equal to tan theta. Is given condition. Now minus 1 less than x less than 1. Here it is tan theta, here it is tan pi by 4, and here it is tan minus pi by 4. We already seen, so this is your guidance video. Now here theta, here pi by 4, here minus pi by 4. It always less than. So order sign remains as it is, and because of tan is increasing in every quadrant. Clear? So once again multiply by 2 minus pi by 2 less than 2 theta less than pi by 2. that is ranging of stain as well as sine. Now what is given? Therefore y is equal to cos inverse 2 tan theta upon 1 plus tan square theta, that is cos inverse sin 2 theta sin 2 theta, and that gives us pi by 2 minus sin inverse sin 2 theta, because of sin inverse is plus cos inverse is equal to pi by 2 mod x less than 1, and see here sin increasing in fourth and in the first quadrant, so minus 1 less than sin 2 theta less than 1. Sin 2 theta less than 1. So it is in range. So we can write this in part. So what we get here? So that is equal to pi by 2 minus 2 theta, because minus pi by 2, because minus pi by 2 less than 2 theta less than pi by 2. Rest of part as per previous example. So I'm leaving for you. What will be the dy by dx? Answer is minus 2 over 1 plus x square. Pi by 2 minus 2 tan inverse x. So as per previous sum. Next. See. Y is equal to sin inverse 2x under root 1 minus x square. Condition is given minus 1 upon root 2 less than x less than 1 upon root 2. In that inverse trigonometric form, here less than or equal to is given, and we already seen that we already proved that is equal to 2 sin inverse x. Here also we are going to see. So what we have to take, suppose sin inverse x is equal to theta. Why sin inverse x is equal to theta? X is equal to sin theta. 2 sin theta under root 1 minus sin square theta. That comes out cos square theta. That comes out cos theta. So 2 sin theta cos theta. It is formula of sin 2 theta. Outside sin inverse is there. Clear? So sin inverse, they try to make into bracket whatever may be in terms of sin. This is the reason why we are supposing sin inverse x is equal to theta. And therefore x is equal to sin theta. Now use given part minus 1 upon root 2 less than x less than 1 upon root 2. This implies sin minus pi by 4. Yes or no? Yeah. Sin theta less than sin pi by 4. Yes. So this implies minus pi by 4 less than theta less than pi by 4. Why? Because sin is increasing in first and fourth quadrant. That we know. Here we get sin 2 theta, so we need to multiply by 2. So minus pi by 2 less than 2 theta less than pi by 2. Yeah. Now, what is y? And therefore y is equal to sin inverse 2 sin theta under root 1 minus sin square theta. That is equal to sin inverse 2 sin theta mod cos theta. We don't know whether it is positive or negative. This is reason why mod. That is equal to sin inverse 2 sin theta into cos theta. Why? Because minus pi by 4 less than theta less than pi by 4. So it is fourth and first quadrant, and we know that in first and fourth quadrant cos function is positive. Now recall that standard form. That is equal to sin inverse sin theta. And we know that sin inverse of some function is equal to some function. When? Only when that is in range. And of course here it is in range. Minus pi by 2 less than 2 theta less than pi by 2. So that is 2 theta. Replace value of theta. That is 2 sine inverse A. So remaining step is differentiate with respect to x on both sides. So on left hand side y is there. So therefore y is equal to this one. So d by dx of 2 sine inverse A. Two constants, so take it outside. D by dx of sine inverse A. What is the formula of sine inverse something? D by dx of sine inverse something is nothing but 2 over under root 1 minus something square d by dx of something. So 2 over under root 1 minus x square. Here. Next, see. Find dy by dx y is equal to sec inverse participle. Now see. For sec inverse, here if it is in terms of cos, then it comes out sec. So here we need in terms of cos. 2 cos to theta have 4 forms. Cos square theta minus sin square theta, that is in terms of cos and sine. Cos to theta in terms of cos and sine. Now cos to theta in terms of cos, 2 cos square theta minus 1. See? In place of 1 minus 2x square minus 1, if 1 minus 2x square is written, then we have to take sin theta. Why? Because 1 minus 2 sin square theta is equal to cos 2 theta. And remaining well-known form in terms of 10, 1 minus 10 square theta upon 1 plus 10 square theta. And we already noted all these standard forms in 11. So what we have to take, suppose cos inverse x is equal to theta. So what we get, x is equal to cos theta. Now use given condition. 0 less than x less than 1 upon root 2. Yes, what is x? X is cos theta. What is cos? Cos pi by 2, then it comes out 0. And here what is it? Cos pi by 2. So pi by 2 greater than theta greater than pi by 2. Why? Cos is decreasing in first order. So order sign changes. So what we get? This implies pi by 2 less than 2 theta less than pi multiplied by 2 and writing in our same manner. And therefore, what is y? Sec inverse 1 upon 2 cos square theta minus 1. And that is equal to sec inverse 1 over cos 2 theta. That is sec inverse sec 2 theta. That is 2 theta. Why? In terms of sec inverse, where it is? Pi by 2 less than 2 theta. If we write in terms of interval, then 2 theta belongs to pi by 2 to pi. And it is a subset of closed interval 0 to pi except pi by 2. We know for sec inverse. It's a part of this thing, so this comes there. So that is equal to what? Replace value of theta 2 cos inverse. Therefore, what we get? Y is equal to this one. So write that line, differentiate with respect to x on both sides. So what we get? So we get dy by dx is equal to d by dx of 2 cos inverse 2 outside. D by dx of cos inverse x. What is cos inverse something? That is equal to 2 into minus 1 upon 1 under root 1 minus something square d by dx or something or some function. That is minus 2 over under root 1 minus This is the answer. Next one. See, very simplest form is that. What is title? Exponential logarithmic functions. See, this one is the exponential form, this one is the logarithmic form. Exponential and trigonometric. See, trigonometry, inverse trigonometry in exponential form. Here it is given in division form. Just apply division rule. Use that e raised to something is equal to some function is equal to e raised to some function by some function. Very simple things are there. So, I am leaving second and third for homework. Let us start with first one. Take that is equal to y upon sin x, differentiate with respect to x. So what we get? Dy by dx is equal to d by dx of e raised to x over sin x. Yes or no? Yes. So now apply the rule. Denominator quantity whole square. Denominator quantity as it is. Derivative of numerator. Numerator as it is. Derivative of denominator quantity. As far as division rule is concerned. So that is equal to sin x d by dx of e raised to something. E raised to something d by dx of something. E raised to something. Sin something, cos something, we know it. Cos something and d by dx of something over sin square x. Now take e raised to x common. What we get? Sin x minus cos x over sin square x. And that comes out 1 over. See, from this one you can get this term directly also. That will get e raised to x common, sin x over sin square x, cosec x, cos x over sin square x, cosec x over x. From this one you cannot direct this step also. Yeah, this is the answer. Now see. Now what is given? Sine of fourth one is given. Y is equal to sine of tan inverse e raised to minus x. No problem. Here, differentiate with respect to x. So what we get? Dy by dx is equal to d by dx of sine of tan inverse of e raised to minus x. No problem. That is equal to sine something cos something into d by dx of something. What is something? Tan inverse e raised to minus x. Something form is there. Cos of tan inverse e raised to minus x. Tan inverse something. 1 upon 1 plus something square d by dx of something. That is equal to cos of tan inverse e raised to minus x. 1 upon e raised to minus 2x. E raised to minus x whole square is e raised to minus 2x. E raised to something, d by dx of something. Right last derivative first, what is e raised to minus x? So minus 1. So minus, right, e raised to minus x, e raised to minus x, cos of tan inverse e raised to minus x over 1 plus e raised to minus 2. This is the answer. Okay. What alternative form is given? Just apply something form, then it is very easy for you. Next one, y is equal to log cos e raised to x. Y is equal to log cos e raised to x. Yes, that is given to us. Very simple. differentiate with respect to x. So what is dy by dx? Dy by dx is equal to d by dx of log of cos of e raised to x. See, log some function 1 upon some function d by dx of cos of e raised to x. Cos some function minus sin some function into d by dx of some function e raised to x. So that is minus 10 e raised to x. What is d by dx of that one? E raised to x into d by dx of x. E raised to some function d by dx of some function. So write last derivative first. Minus e raised to x, 10 e raised to x is done. Next one, it is starting from e raised to x to e raised to x raised to 5. Next one, y is equal to e raised to x, e raised to x squared, e raised to x cubed, e raised to x raised to 4, e raised to x raised to 5 is given. It is just exponential form. Differentiate with respect to x, here directly go to differentiate. So dy by dx is equal to d by dx of radical term e raised to x, e raised to x squared, e raised to x cubed, e raised to x raised to 4, e raised to x raised to 5. Okay. So that is equal to d by dx of e raised to d by dx of e raised to x squared, d by dx of e raised to x cubed, plus d by dx of x raised to 4, d by dx of e raised to x raised to 5. So that is equal to what? E raised to some form into d by dx of some, e raised to something, d by dx of something, e raised to something, d by dx of something. Same way, e raised to something, d by dx of something, e raised to something, d by dx of something. Yes or no? Yes. So that is equal to e raised to x plus, what we get here? E raised to x square into some function square, 2x into d by dx of some function, plus here what we get? E raised to x cubed. So nx raised to n minus n, some function raised to n times some function raised to n minus 1 d by dx of some function e raised to x raised to 4. What we get? 4x cubed into d by dx of x plus e raised to x raised to 5x raised to 4 d by dx of x. So ultimately what we get? E raised to x, 2x, e raised to x squared, here 3x squared, e raised to x cubed, here 4x cubed, e raised to x raised to 4, and from here 5x raised to 4, e raised to 5. This is the answer of this question. Yes, this one. Yeah, sixth one. Yeah, yeah. Next. Once again, very simple form is there. See. Log something 1 upon by dx of something. Here you need to apply division rule. Here. Yx greater than 1, x greater than 1, then log 1 greater than 0. So whatever may be here is positive to define logarithmic function. Here only x is there, so x is greater than 0. So leave this one for you, just apply division rule, just apply something for. Let us try to see these two. See, y is equal to root of e raised to root x. No problem, differentiate it. Differentiate with respect to x. So what we get? dy by dx is equal to d by dx root of e raised to root x. What is root something? Root some function 1 upon 2 root some function d by dx of some function. What is some function in our case? E raised to root x. So 1 upon 2 e raised to root x, e raised to some function, e raised to some function, d by dx of some function. So one of them get cancelled. What we get? So root of e raised to root x upon 2, that get cancelled. Root some function 1 upon 2 root some function d by dx of some function. So what we get? 1 upon 4 root x root of e raised to root x. This is that of this question. Next, what is taken given here? 10 y is equal cos of log x plus e raised to x. Same line, differentiate with respect to differentiate with respect to x. And therefore what we get? dy by dx is equal to d by dx of cos of log x plus e raised to x. Cos of some function minus sine of some function into d by dx of some function log x plus e raised to x. Here addition is there, so apply addition rule. Minus sine of log x plus e raised to x into bracket d by dx of log x plus d by dx of e raised to x. And that comes out minus sine of log x plus e raised to x. What is d by dx of log some function? 1 by some function d by dx of some function e raised to some function d by dx of some function. That converted into so 1. So write last derivative first. Minus of 1 by x plus e raised to x. Sine of log x plus e raised to x. Is that? Yes, see here. That means this all the 4 forms are completed. Is it clear? Yes. Next one. See. Logarithmic differentiation. See, whenever more than two functions are in product form or division form or mixed form, then take log on both sides. Then take log on both sides. Okay. That means with help of logarithmic form, we can differentiate these functions. Now what is given here? Can I write y as a x minus 3 x squared plus 4 over 3x squared plus 4x plus 5 raised to half? Yes or no? Yes, we can take it. Now take log on both sides. Before that thing, let us recall rules of logarithmic function. Log x raised to n log x. If base is not mentioned, we have to understood that base as a e. Clear? Yes. Next one, log xy is equal to log x plus log y. Log x by y is equal to log x minus log y. Clear? Then, see, change of base of logarithmic function. This part is important for us. We can take differentiation of logarithmic function only when base is e. So, change of base. Log a base b is given to us, right? Log a over log b, whatever may be you want to mention here. So, for example, log x base y is given. We can write that is equal to log x over log y base is e. Change of base. Yes. See, these are the properties of logarithmic functions. Yeah, this one. Using these properties, simplify this one. Okay. And therefore, log y is equal to log x minus 3 x squared plus 4 over 3x squared plus 4x plus 5 raised to half. So first of all, n log x. So half of log of x minus 3 x squared plus 4 over 3x squared plus 4x plus 5. Now log x by y. So that is equal to half of log of x minus 3 x squared plus 4 minus log of 3x squared plus 4x plus 5. Now see here also one thing is that log xy. One more step we can write it. And therefore what we get? Log y is equal to half of log x minus 3 plus log x squared plus 4 minus log of 3x squared plus 4x plus 5. So this is the simplification with help of log. See, if we differentiate directly, it is very hard to differentiate. First of all, we have to apply rule something, then division rule, in between division rule, we need to use product rule. So it is very, very lengthy. So, but if we convert it in terms of logarithmic function, then it is very easy. See, now we have to differentiate this form. Clear? So, what we have to write? Differentiate with respect to x. So, what we get? d by dx of log y is equal to d by dx of half of all this form. Log x minus 3 plus log x squared plus 4 minus log of 3x squared plus 4x plus 5. That is equal to, therefore, d by dx of log y base is equal to half of. Apply working log differentiation. Give differentiation to term by term. D by dx of log of x minus 3 plus d by dx of x squared plus 4 minus d by dx of log of 3x squared plus 4x plus 1. Log something, 1 by something, d by dx of something, 1 by 2. Log something, 1 by something, d by dx of something, 1 by something. X squared plus 4 d by dx of something minus 1 by something 3x squared plus 4x plus 5 into d by dx of 3x squared plus 4x plus 5. Here. So, what is dy by dx? Dy by dx is equal to y by 2. Is a linear form. What is derivative 1? So 1 over x minus 3 plus d by dx of x square is 2x into dx by dx 1 plus derivative constant term is 0 over x square plus 4 minus 3x derivative of x square is 2x. So ultimately it comes out 6x. Derivative plus 4x is 4 and derivative constant term is 0 over 3x squared plus 4x plus 5. Okay. See, this is the answer of this question and it's of 4 marks. 4 marks questions. See. Differentiate this function with respect to x. Next. See here, yes. Differentiate x raised to sin x greater than 0. Friends, here it is given of this form. Exponential form is given. Function raised to function is given. Function raised to function is given. Then take log on both sides. Log y base e is equal to log fx raised to gx base e. Now log x raised to n. So log y base e is equal to gx into log fx base e. So function raised to function is converted into product. If we take log on both sides. Now it is easy to differentiate it. Or one more form is there. See, if I take fx is equal to a raised to x and gx is equal to log x base a, exponential function, logarithmic function. Exponential function, logarithmic functions are inverse of each other. G is the inverse of f. So f of g is equal to identity function. So f of g at x is equal to identity function at x. And that is x. And this is f of g of x, that we know. G of x is nothing but log x base a is equal to x. So, what is f of something? A raised to something. For second part, what we need to use? Or y is equal to fx raised to gx is given. Then we can write that is equal to e raised to log e fx raised to gx base e. So that is e raised to gx into log fx base e. Is also converted in terms of product form, but as a power of exponential function. Either use, now we are easy to differentiate it. We can differentiate it. In the same way, we can differentiate this part also. Here, either you can take log on both sides, that can be also work, or you can convert into exponential form also. Let us see one example, simple example in both methods. And you can choose any one of you, convenient to any one of you. See, let us consider very simple example. Y is equal to a raised to x. First of all, I am taking log on both sides. Log y base e is equal to log x to the power base e. See. And this implies log y base e is equal to x log x base e. Now it is in product form. Differentiate with respect to x on both sides. So what we get? D by dx of log y base e is equal to d by dx of x log x base e. See here? And therefore, what is log something? Log some function, 1 by some function, d by dx of some function. Here product form is there, so apply product rule. D by dx of log x base e, log x base e into d by dx of x. So what we get here, dy by dx is equal to y into x. Log some function, 1 by some function, d by dx of some function. Plus log x base, because this is 1, once again this is 1. Where replace value of y, x raised to x by x, 1 plus log x base e. When if you take log on both sides. Let us see second way. Or y is equal to x raised to x is given. Can I write e raised to x base e? Can I write that is equal to x log x base e? Yes. We can write this one. Now differentiate. Differentiate with respect to x. So, and therefore dy by dx is equal to d by dx of e raised to log x base e. E raised to some function, d by dx of some function. Now, this one, try to make it same form, x raised to x base e, converted it into original form. Apply product rule, x into d by dx of log x base e, log x base e, d by dx of x. What is this one? Is nothing but x raised to x. Here what we get? X into 1 by x, dx by dx plus log x base e. So that is equal to x raised to x into 1 plus log x base e. There, see here. Either we apply this rule, we get the same answer, or we can apply in this way also. Now, see here. Here function is given x raised to sin x. X raised to sin x. Take y is equal to x raised to sin x. Take log on both sides. Then it is very to differentiate it. Clear? So I would like to give homework. X raised to sin x raised to x, y is equal to cos x raised to sin x. Try to see these three sums. Yeah. In next lecture we are going to move more example based on function raised to function. Thank you, dear friends.